Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 4.9. I'll go ahead and read the problem statement. It says, strawberries contain about 15 weight percent solids and 85 weight percent water. To make strawberry jam, crushed strawberries and sugar are mixed in a 45 to 55 mass ratio, and the mixture is heated to evaporate water until the residue contains 1/3 water by mass. Okay. It says, Part A, draw and label a flowchart of this process. So here, maybe I'll just kind of go through and highlight, underline where I'm talking about in red right here. So this part right here is just the information we got from the problem statement. This is the strawberries by mass. It's the feed that's going in, or one of the feeds going in. Then we have a sugar feed going in, and they're mixed at this ratio. And then we know that in the dryer, what comes out is 1/3 water by mass. That's what they gave to us. I tried at first to kind of record and do all this problem so that you guys could see me just working through it, but I don't work through these problems particularly fast, and I think the video would end up being too long. And so I've already written down the answers here, and I'll just kind of talk through them and what my thought process was as I was going through it. Okay, part B, it says, do the degree of part A, we're still on part A. We're doing the flowchart process. Okay, so this is my flow diagram here. I've got two feed streams going into the mixer. We've got a mixed stream coming out, which is fed into the dryer, and then the dryer has two outlet streams. It doesn't really talk about it, but the water, by the law of conservation of mass, the water has to be coming out somewhere. So you have to remember to say, okay, I have a certain amount of water coming out. Stream 5 is my water stream coming out. Whether that's just steam kind of boiling off the top of the pot or, whatever. Then this is our jam stream, product stream coming out. Okay, part B. Do the degree of freedom analysis and show that the system has 0 degrees of freedom, i.e. the number of unknown process variables equals the number of equations relating them. If you have too many unknowns, think about what you might have forgotten to do. I wonder if they're kind of referencing this because they didn't explicitly say that there's a water stream coming off, so remember to put that in. Okay, well, there are 9 unknowns and there are 8 system parameters. Okay, so there are not enough unknowns, even though they said there's 1 degree of freedom, and then in the next part C, they actually specify that degree of freedom right there. So that eliminates that. Otherwise, we would just set our own mass basis. So we could set a mass basis for, mass 1 or something like that, and then we have a mass basis for the whole system. It kind of eliminates all of the, mass 1, mass 2, mass 3, mass 4, mass 5, all of those if you don't have it set. So we're just kind of going off of, what we've got here, and then they give us this last one that we would have needed. Okay. So we have 3 material balances for the mixer, and then we have 3 material balances for the dryer, and then we have 2 process specifications. So one process specification is this guy right here, I highlighted in blue. You can see that this plus this plus this has to equal 1. So that's a process specification we could use. The other process specification we need to use is that the strawberries are 15 weight percent solid and 85 weight percent water. Okay, that comes into play here when we need to calculate the number of, or the weight of berries solids and the weight of water in the exit of the mixer stream. So let's go ahead and do that. They give us this last process variable. I highlighted it in blue as well, so if we just highlight that blue, then this becomes a 3, and then we do have the number of degrees of freedom that we need. So then it would be 0 degrees of freedom. Okay, so we're going to use this this information, this process information right here, in order to calculate what these two unknowns are. And I just did that really briefly right here. Okay, so we've got a certain amount of weight percent of berry coming out of the mixer. Well, that means that 85% of that percent is going to be water, of course, and 15% of this 45 weight percent is going to be, of course, the berry solids. Okay. Part C, calculate how many pounds of strawberries are needed to make 1 pound of jam. That's where this 1 pound came from. Okay, so we're going to do our material balances now. First, we'll do our material balances around the dryer. Then we'll do our material balances around the mixer. Okay, for the dryer, we have our water material balance, our sugar material balance, and our berry solids material balance. Then I added one more process spec. I should highlight that in blue. That process spec is the one we talked about earlier, which is this process spec. Okay. I've highlighted the unknowns, and then I've put a little green counter next to, a green counter like this, next to if we've seen the unknown before or not, so that we can keep track of how many unknowns we have. So that by the end, we'll have a certain number of equations and a certain number of unknowns, and then we'll use that system of equations in order to solve for all of these variables. You can either do this through substitution, or you can do it through solving a system of equations using linear algebra. I use the linear algebra approach. I think it's a lot less writing for me, and I write kind of slow, so I just like typing it into the computer and then having the computer solve the system of equations. So otherwise, these problems can get a little tedious trying to solve each variable one at a time. Okay. Over here in red, I have, you'll see this number circled here, 1, 2, 3, 4. That's keeping track of how many equations we have. So we have a green counter, that's our number of unknowns. Then we have our red counter, that's our number of equations. Okay. Then we have our material balances, same material balances around the mixer. And you'll notice that we have 6 unknowns and 7 equations. So I've over specified this, or I've used too many material balances. So you can use the 3 material balances over the full process here and here, but when you do it for the whole thing, because they share stream 3, I've created too many. I've created a redundant equation, so one that we don't actually need, because I use stream 3 twice. Okay, and so that's why we end up with 7 equations. I could also make an 8th equation, which would be m1 plus m2 plus equals m4 plus m5. So you can make a lot of equations, but these equations are not independent. Okay, so we ran out of independent equations. So when you're solving this system of equations, you can use any of these equations, and you can come up with more equations that are all true. They just won't necessarily help you in solving the problem, and especially if you're using a system of equations to solve for what the answer is. Using linear algebra, you need to make sure that the number of equations you're using matches the number of unknowns you're using, or else you will have too much information. It kind of says like the color of this is white. It doesn't give us any extra important information about the unknowns themselves if we give too much information. So you want the number of equations to match the number of unknowns. So I've got 7 equations here. I've got 6 unknowns. So we overspecified it. So we'll not use equation 7 when we solve. I'll just use equations 1 through 6, and then I will use equation 7 to check my answer and see if it makes sense. Okay. So I solved the system of equations using linear algebra. Just 6 equations, 6 unknowns. You just set up your equations. I don't think I have to show you guys how to solve that. You can use a computer to solve that. You can use Excel. You can use a calculator. You can also just solve all of these equations one at a time using substitution as well. The answer to that system of equations is here. And then you can see I checked with equation number 7 here. I got that mass of stream 2 times the weight percent of very solids equals the mass of stream 3 times the weight percent of very solids in stream 3, and that I got the that they equal the same amount. So this equation is true. So equation 7 that I used to check is actually shows that we didn't mess up when we were plugging in numbers or whatever. So this looks to be good to go. So the answer is you need about 0.59 pounds of strawberries in order to make 1 pound of jam. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.